Okay, so welcome back to our discussion on transportation model or transportation problem. For this video, this will be the last video for this topic, and here we will discuss our second example entitled Andy and his toy manufacturing plants. We will no longer give the word problem, but instead start from the transportation model. So the transportation model gives us two plants, A and B, with supplies 400 and 400, and destinations city X, Y, and Z with demands 300, 200, and 300. So we can think of these values as boxes of toys. And then the numbers on the upper right corners are the unit shipping cost. Okay? So as mentioned in the previous videos, in order to solve these transportation problems, we have to carry out the northwest corner rule and the stepping stone method. So for the northwest corner rule, we have exhaust the supplies of the first plant. So in this case, we will put 300 here. The excess 100 goes to the second cell. Now we have not met the full demand of CTY, so we will exhaust the demands as supply of plant B. So this will be 100 and then the excess 300 goes to the next cell. So in other words, the northwest corner rule will give us this updated transportation model. Now let's compute the transportation cost. So in this case, we will have 300 times 8 plus 100 times 9 plus 100 times 7 and plus 300 times 8. So if we compute that, you will get $6,400. So this is our initial transportation cost, and this is what we want to check if we can still lower or not. So to check if we can still lower the $6,400, we have to do the stepping stone method. Now to do the stepping stone method, we have to compute the improvement indices of the unused cells. In this case, the unused cells are plant B, CTX, and plant A, CTZ. So these are the unused cells. Computing the improvement indices, we have to draw the closed polygonal paths. So we have this closed polygonal paths for plant B CTX. So the improvement index is 7 minus 8 plus 9 minus 7, which is positive 1. On the other hand, for plant A CTZ, we have this closed polygonal path. And then computing the improvement index, we have 7 minus 8 plus 7 minus 9, you get negative 3. Now, because we have a negative improvement index, this means that the transportation cost of $6,400 can still be lowered. So we choose the most negative improvement index. Now, in this computation of negative 3 improvement index, the negative signs are with negative 8 and negative 9. This corresponds to the cells right here, 100 and 300. So let's put these numbers inside the oval, as this signifies that this is where we will move boxes of toys. Now between 100 and 300, which one is lower? We see that the lower of the two values is 100. So what we will do next to improve the transportation cost is we move 100 from here to here, and we will move 100 from here to here. So in other words, we will subtract 100 from numbers inside the oval, and then we will add numbers to cells outside the oval. So add 100 here and over here. So if we do that, we have this updated transportation model. Now, when we updated the transportation model, we don't have to compute the transportation cost. We can check the improvement indices instead. So, in this updated transportation model, we have plant A, CTY as unused cell, and plant B, CTX unused cell as well. So let's compute the improvement indices of these two. For plant B CTX, the improvement index is 7 minus 8 plus 7 minus 8, you get negative 2. And then for plant A CTY, we have this closed polygonal path. And then computing the improvement index, we have 9 minus 7 plus 8 minus 7, you get positive 3. Now, because we still have a negative improvement index, this means that the transportation cost can still be lowered. We did not compute the transportation cost earlier, but we know that it can still be improved based on the improvement indices. Now, when we computed the improvement index negative 2, we have negative signs, negative 8 and negative 8 right here. So let's put this negative signs correspond to these cells, 300 and 200. So let's put these numbers inside the oval, as this signifies that this is where we will move boxes of toys. Now, between 300 and 200, the smaller of the two values is 200. So what we will do is we will subtract 200 from numbers inside the oval, and we will add 200 to cells outside the oval. So add 200 here and add 200 right here. So if you do that, we will have an updated transportation model like this. So again, we don't have to compute the transportation cost, but we have to check the improvement indices. So in our improved or updated transportation model, the unused cells are plant A CTY and plant B CTZ. Now let's compute the improvement indices of these two. So for plant B CTZ, the improvement index is positive 2. And then for plant A CTY, the improvement index is positive 1. So notice that the improvement indices are positive or 0, and hence we cannot lower the transportation cost anymore. So this means that this transportation model right here will give us the minimum transportation cost already. So let's compute the, okay, so as mentioned earlier, the minimum shipping cost or transportation cost is already achieved in this case. So if you compute the transportation cost, you have 100 times 8 plus 200 times 7 plus 200 times 7 plus 300 times 7, which is a total of $5,700. And this is already the minimum transportation cost. So this ends the lecture on transportation cost, rather transportation problem. If you have questions, please comment below and I will attend to them. Thank you.